the simplest way to come up with a top-down hierarchical clustering is to take our good friend k-means and just modify it for that purpose. So one very simple way in which you could use k-means to produce hierarchical clustering is to just run it recursively. Right? So you take your data set, you run k-means, say I run k-means with k equals to 2. What k-means is going to do is it's going to partition the set of points into two clusters. And whether that's a reasonable partition is another question, but k-means will do it. Right? It will say, so these points are aligned to the red cluster and these points are aligned to the yellow centroid. And then what you do is you take a subset of the red points and then run k-means on it again. Maybe with the same value of k, and also run k-means on the set of yellow points. So what that will do is that will continually fracture your clusters. So at the second iteration, I'll be running k-means with k equals to 2, and I'll be taking the red cluster and partitioning it into two further subclusters. So maybe I'll get a purple cluster and a red cluster, and the same will happen with the originally yellow cluster. That'll get broken into yellow and green. And the key thing about this algorithm is at each iteration, it will be operating on a subset of points. So once I've decided to put all the red points into one group, I'm never ever going to consider merging them with another group. Right? So I do clustering entirely within the subset of the points that were colored red. That makes the algorithm efficient because I am recursing on smaller and smaller subsets of the data, but it does make it have this annoying property that, look at the set of points that I end up with. I have the 3 red points here and the 3 yellow points. These are pretty close to each other. Right? They could make a pretty good cluster. Recursive k-means will never find that cluster. It has no hope of finding that cluster because at the first iteration, it split them up into two groups. So once you split it into two groups, you cannot remerge any part of it. And it'll just happily continue recursing until you end up with singleton clusters. So that's a way to use k-means. It's a very simple formulation. It has pretty good computational complexity. If you think about this operation, for k equal to 2, on each iteration, you'll be splitting your data set roughly in half. Right? So if you have 1,000 data points, after 10 iterations, you will end up with singleton clusters because 10 binary splits is going to give you about 1,000 singletons. So the depth is going to be logarithmic. It's going to be log base k of n, where n is the number of instances in the data, and k is the branching factor. K is into how many clusters you're clustering at each iteration of the algorithm. So it's going to produce this fairly quickly. But it will have the annoying property that nearby data points may end up in different clusters.